Hello, my name is Anthony Mosharafa, and this is my TinkerCAD simulation for the TrashBot section of the Home Aid Robots project. TrashBot is designed to check household trash cans, determine whether they're about 80% full, remove the trash bag if it is safe, replace the liner, and carry the full bag to a selected drop-off location. First, I will briefly explain the circuit. The Arduino Uno is the main controller. The breadboard is used to organize power and ground connections. The L29 3D motor driver controls the DC motor, and the 9-volt battery powers the motor side of the circuit. In the physical TrashBot design, 4-geared DC motors will drive the robot's wheels. In this TinkerCAD simulation, one DC motor represents the overall drivetrain, so the circuit stays easier to read and test. The ultrasonic distance sensor represents TrashBot's fixed object detection system. It checks whether furniture, walls, or other objects are within 8 inches of the robot. The PIR sensor represents the moving obstacle system, which detects people or pets in the robot's path. The alert LED over here represents the user notification system when the robot detects a problem. The 4 potentiometers simulate adjustable sensor inputs. The first potentiometer on A0 represents the trash can fullness sensor. A high value means the can is about 80% full. The second potentiometer on A1 represents the load or force sensor. A high value means the trash bag may be too heavy, stuck, torn, or unsafe. The third potentiometer on A2 represents the battery level. A low value means the robot needs to return to its charging station. The fourth potentiometer on A3 represents whether replacement liners are loaded. A low value means the liner cassette is empty or not loaded correctly. The 3 servo motors represent the main mechanical actions of the robot. The first servo motor represents the lift mass that raises the bag into the onboard storage bin. The second servo motor, the first servo motor is the gripper that closes around the top of the trash bag. The second servo motor represents the vertical lift mass that raises the bag into the onboard storage bin. And the third servo motor represents the liner cassette roller that feeds a clean liner into the trash can. Now I will briefly show the code. The code starts by including the servo library and creating 3 servo objects. It then defined pins for the ultrasonic sensor, PIR sensor, potentiometers, servos, DC motor, and alert LED. In the setup function, the pins are initialized, the servos are attached, and the serial monitor begins. In the loop function, here, the program reads the ultrasonic distance, PIR value, fullness value, load value, battery value, and liner value. The code then checks conditions in order. Low battery, person or pet detected, fixed obstacle detection, trash can not full, no liners loaded, heavy or unsafe bag, and finally, successful trash can removal cycle. I will now start the simulation and open the serial monitor so the sensor values and robot decisions can be seen. First, I will demonstrate a successful TrashBot cycle. For this test, the battery value is above 250. The ultrasonic sensor distance is greater than 8 inches. The PIR sensor is not detecting any motion. The fullness value is above 820. The liner value is above 500, and the load value is below 800. These are safe operating conditions. The serial monitor shows that the trash can is full and safe to remove. The gripper servo closes to grab the trash bag. The lift servo raises the bag vertically. The liner servo activates to feed a clean replacement liner. And the DC motor runs to represent driving the full trash bag to a drop-off location. The serial monitor then prints that the trash cycle is complete. Oh, looks like I missed. No, that's not better. Here we go. So as you can see on the serial monitor here, full trash bag deposited, cycle complete. Okay. Next, I will demonstrate the low battery condition. I will turn the battery potentiometer below 250. So we'll just drop it all the way down. And then as you can see, immediately prints low battery. Alert LED comes on. Now I'm going to reset the battery. And let's check for obstacle. So we'll move this within 8 inches. Obstacle within 8 inches, stopping and rerouting. You can see the alert LED comes on. Then let's demonstrate the motion from the PIR sensor. So let's put this back above 8 inches. And let's move this around. As you can see, person or pet detected, stopping for safety. So that works as normal. So let's reset that back to no motion. So now we're going to do the fullness check. So let's drop the fullness potentiometer. So as you can see here, it prints trash can is not about 80% full, and it does not continue on with replacing and throwing out the trash. Let's turn this back up to above 80. Now we'll demonstrate the missing liner condition. So we'll drop the liner down. No liner is loaded. As you can see, the alert LED comes back on, and it does not continue on. So let's throw this back up, and let's now check the force. If the force is above 800, then the robot's going to stop. Bag unsafe or over 10-pound limit is printed. LED comes on, and it does not continue through the cycle. Now let's reset all of these back to safe conditions. Battery's high, the ultrasonic distance is safe, the PIR sensor is not detecting motion, the trash can fullness value is high, the liner value is high, and the load value is safe. The robot completes the full successful sequence again. It identifies that the can is full, grabs the bag, raises it into the onboard bin, feeds the clean liner, drives to the drop-off location, and prints that the cycle is complete. The simulation demonstrates the TrashBot algorithm from section 5.3.2. Sensor inputs control the correct actuator responses, and the serial monitor messages show the information that would be sent to the user or operator during each condition. The simulation also shows how the TrashBot meets the main requirements for detecting an 80% full trash can, avoiding fixed and moving obstacles, checking the 10-pound bag limit, replacing liners, alerting the user, and stopping safely when a problem occurs. Thank you.